In this video, we'll take a look at section 24.1, tangents and normals. So a tangent line, the derivative of a function dy dx, is the general equation for the slope of a tangent line. Once we have a slope m and a point x1, y1, we can write the equation of the tangent line in point slope form. Y minus y1 is equal to m times x minus x1, and then solve for y to get it in slope-intercept form. So far we found the derivatives and substituted our x values in to get the slope. Now we're going one step further to find the actual equation of the tangent line. So first example, just using the formula, find the equation of the line with a slope -2 that passes through the point 1, -7. So this is our slope m, and it's going to be a slope of our tangent line, and our point x1, y1. Substitute, we get y minus our y coordinate, -7, is equal to the slope, -2, times x minus 1. So y plus 7 is equal to -2 times x minus 1 is the equation of the line given in slope-intercept form. If you want in point-slope form. If you want to arrange it into slope-intercept form, solve for y. We get y plus 7 is equal to, distribute the -2, -2x plus 2, subtract 7 from both sides. Y is equal to -2x. Let's see, 2 minus 7 is -5. So this is slope-intercept form. And the one in blue is called point-slope form. Just depends on which one you're looking for. All right, so a couple of examples. Let's say we have the function y is equal to 1/3 x cubed minus 5x, and here's our function graphed. We want to find the equation of the line tangent to the curve at the point 3, -6. So we've got half of what we need. We've got the coordinate 3, -6. Now I need the slope of the line. So to find the slope, take the derivative of your function, dy dx, is equal to 1/3 x cubed, apply the power rule, 3 times a third is 1, x squared. Derivative of minus 5x is minus 5. We want the derivative at x equals 3. So that gives us 3 squared minus 5. 9 minus 5 is 4. So now I have a slope of 4 and a point 3, -6. Now I can substitute that into the point-slope form of the equation and actually find the equation of my tangent line. So we get y minus y -6 is equal to the slope times x minus the x coordinate, which is 3. Y plus 6 is equal to 4x minus 4 times parentheses x minus 3 is my point-slope form. Then if you want slope-intercept form, go ahead and multiply. We get y plus 6 is equal to 4x minus 12. Subtract 6 from each side. We get 4x minus 18. So there's our equation for our tangent line in both forms. Next example involves a circle. We have the circle x squared plus y squared equals 25 at the coordinate 3, 4. Taking the derivative, we get the derivative of x squared is 2x. The derivative of y squared with respect to x is 2y dy dx. Derivative of 25 is 0. Take the 2x to the other side. Divide both sides by 2y. And we end up with -x over y. So the slope, when x is equal to 3 and y is equal to 4, substitute 3 and 4 into our equation, and we get -3/4. And then we have our point 3, 4. So we get y minus 4 is equal to -3/4 times x minus 3. And for this one, I'm going to go ahead and leave it in point-slope form. But you can multiply it out, solve for y, and you'll also have slope-intercept form. So that's tangent lines. Now that you've found the slope, now we can also use the given point and find the tangent line, the equation. Now we want to take a look at something called a normal line. So a normal line is a line perpendicular to the curve, consequently perpendicular to the tangent line. If you remember from algebra, slopes of perpendicular lines are negative reciprocals. Change the sign, flip the fraction. What does that mean? If I have a line where the slope is equal to 2, then the line perpendicular to that means it meets it at a right angle. That's called a normal line. The slope of that line would be the negative reciprocal of my other line. So let's go back and take a look. Find the equation of the line normal to the indicated curve at the given point. So what we're going to do is we're going to do the same thing we did before. We're going to find the slope of our tangent line, and then we're going to take the negative reciprocal for the slope of our normal line. All right, so our first function, y equals 8 minus x cubed. The slope of the tangent line, dy dx, is equal to the 8 drops off, and we get negative 3x squared. At x equals negative 1, I get negative 3 times negative 1 squared, which is negative 3. So the slope of the tangent line is negative 3. The slope of the normal line is the negative reciprocal, which ends up being positive 1/3. So now the slope of the normal line is 1/3, and we have our point negative 1, 9. So we get y minus 9 is equal to our slope 1/3 times x minus 1 minus a negative turns into x plus 1. All right, next example, we've got a hyperbola, and we have a coordinate 3, 1, and we want to find the equation of the normal line. And if you can see, it's hard to see, but it's in yellow. So find the equation of the first derivative, substitute a 3 to get the slope of the tangent line. Derivative of x squared is 2x, minus derivative of y squared is 2y dy dx is equal to 0. Take the 2x to the other side, so I can solve for dy dx. Divide both sides by negative 2y. I get dy dx is equal to positive x over y. So the slope of the tangent line is substitute x equal 3, y equal 1, and we get 3 over 1. The slope of the tangent line is 3, so the slope of the normal line will be the negative reciprocal, negative 1/3, with our point 3, 1. Put in the point slope form, we get y minus 1 is equal to negative 1/3 times x minus 3. And there's our equation in point slope form. All right, a few more examples, some in-class practice. Find the equations of the line's tangent or normal to the given curves with the given slopes. So now we're given the function y equals x squared minus 2x, and we're given that the tangent line has slope 2. So to find the equation, what we're missing is the point. So find the derivative of our function, dy dx, is equal to 2x minus 2, and now we know the slope equals 2. So substitute 2 in for dy dx. Solve, add 2 to both sides, we get 4. Divide by 2. The x-coordinate of our point is 2. Then to find the y-coordinate, substitute 2 back in the original. I end up with y is equal to 4 minus 4, which is 0. So the slope is 2, and the point is 2, 0. So my equation is equal to y minus the y-coordinate, which is 0, is equal to the slope of 2 times x minus the x-coordinate, which is 2. So simplifying point or slope-intercept form, y is equal to 2x minus 4. All right, next we have the function y equals 1/2 x to the fourth plus 1, and we want to find the normal line with slope 4. Okay, so this time, when we take the derivative, dy dx equals 4 times 1/2 is 2, x to the third, the 1 drops off. If the normal line has slope 4, then the tangent line has slope the negative reciprocal. So we're going to take our equation and substitute negative 1/4 in for dy dx. As we have the slope, we want to find the point. But the derivative gives us the slope of the tangent line, so I have to put negative 1/4 in. Okay. Let's see, divide both sides by 2 or multiply both sides by 1/2. I get negative 1/8 is equal to x cubed. Take the cube root of each side. X is equal to the cube root of negative 1/8 is negative 1/2. So the x coordinate is negative 1/2. The y coordinate is 1/2 times negative 1/2 to the power of 4 plus 1. Negative 1/2 to the fourth is a positive, let's see, 2 to the fourth is 1/16. 1/2 times 1/16 is 1/32 plus 1. That's 32 over 32. I get 33 over 32. So the slope is 4, and the point is equal to negative 1/2, 33 over 32. Put in point slope form, I get y minus 33 over 32 is equal to the slope of 4 times x minus a negative, which is plus 1/2. And there's the equation of my normal line. All right, last example is an application. So we've got heat flows normal to isotherms, curves along which the temperature is constant. Find the line along which heat flows through the point 2,1 and the isotherm along the path 2x squared plus y squared is equal to 9. Heat flows normal to isotherms, so we're looking for the normal line. So find our derivative for the slope of the tangent line. The derivative of 2x squared plus y squared equals 9. Derivative is 4x plus 2y dy dx is equal to 0. Take 4x to the other side. Divide both sides by 2y. Our derivative, dy dx, is equal to negative 2x over y. So now I want to find the slope of the tangent line at x equals 2, y equals 1. So substitute 2, 1 into my dy dx. So I get negative 2 times 2 over 1, which equals negative 4. That's the slope of the tangent line, so the slope of the normal is the negative reciprocal, so that would be a positive 1/4. And the original point I'm given is at the point 2, 1, so I get y minus 1 is equal to 1/4 times x minus 2, and that's the equation of my normal line to that particular isotherm.